Let's start. Unit 3, circles and conics. Guys, a lot of the stuff from here on out this semester is going to be a lot of new material, stuff you've never seen before. Right? So it's going to be a little bit harder than first semester was. We've never seen all these circles and conics. We've never dealt with the trig that we're going to see. We've never dealt with unit circle. Right? It's a lot of new material, so we really need to pay attention. We really need to buckle down. Now, we're talking about conics. Throw it away, Liam. My goodness. Alright. Cutting a cone with a plane. Hey, what's a plane? Not those things that fly around with two wings. It's like it's a straight line, but it's a plane, right? It's made up of lines.
It's like a piece of paper.
3 more points would be a line. No. So a plane is made up of points. It's like a solid sheet. Like if I took this sheet of paper, excuse me. This is a plane, right? It extends forever in all directions. It's two-dimensional. Right? So if I use that to cut a cone, I can get a parabola, which is what we just worked with, right? We just worked with these parabolas. We can get a circle. We get an ellipse if we cut it at an angle, or we get hyperbolas. So those are the 4 different things we're going to talk about in this unit. We've already talked about parabolas when we talked about quadratics. We're going to talk more about circles, ellipses, and hyperbolas this unit. Now today we're not going to do any of that. Today we're going to talk about distance formula and midpoint formula. It's going to be a really tough day.
Actually?
So, no, not actually.
This is from your last year.
Yeah, you've seen both these things before. Today should fly by. So, objective, I can find the distance between 2 points on a coordinate plane, and I can find the midpoint. Pretty easy. So, first we're going to do a little exploration. If you haven't already, please graph those 3 points and label them. You can connect the points. Because it's going to ask us, oh, it does say draw line segments A, B, B, C, A, C. What polygon did we just draw? A right triangle. Right? It's really important to specify that, say right triangle. Right triangle. Sweet. So if I look at my right triangle, what's the length of BC? Well, let's count from B to C. 1, 2, 3, 4. 4 units. The length of AC is 3, right? 1, 2, 3 units. Now, we have a couple more questions here. What's the longest side of a right triangle? Hypotenuse. Coincidentally, the one we don't know. Hypotenuse. What theorem can we use? Pythagorean theorem. What is Pythagorean theorem?
A squared plus B squared equals C squared.
I'm calling somebody. A squared plus B squared equals C squared, right? We can use Pythagorean theorem to solve for that hypotenuse. Because we have our 2 other sides. So let's do it. 3 squared plus 4 squared equals C squared. So 9 plus 16 equals C squared, right? 3 squared is 9, 4 squared is 16. 25 equals C squared. Well, how do I solve for C?
Square root it.
Square root it, so we get C equals 5.
Yep.
So the length hypotenuse is the distance between 2 points. Why did I say it's the distance between 2 points? If we look, the distance between 2 points, A and B. Now, the reason we did this exploration, the reason we're doing it, is to show you the distance formula, where it comes from. It comes from Pythagorean theorem. Right? So if we look at our next page, our distance formula comes from taking x1 and subtracting x2, or x2 minus x1. Either way, right? My x2 value minus x1 gives me this length. My y2 minus my y1 gives me that length. If I square them and add them, and take the square root, that gives me my distance. So the distance formula comes from using a squared plus b squared equals c squared. Now, are you going to be asked to prove that? Not a chance. Right? We're not going to ask you that. We're not going to ask you to do an exploration like this on a test or tell us where it comes from. But it's nice to know where things come from sometimes. So, to use the distance formula, the distance between A and B, x2 minus x1 squared plus y2 minus y1 squared. And the whole thing is under a radical. It's the square root of that. Just like when we solved our Pythagorean theorem. A squared plus b squared, and then we took the square root of it. Right? The distance formula comes from Pythagorean theorem. Okay? It's pretty simple, pretty easy. This you have to know. You have to know distance formula. But that's easy to remember. Any questions so far? I know I kind of flew through that, but I want to go quick. Okay, let's keep going then. Find the distance of C to D. So, use our distance formula. Square root x2, 4, minus x1, so plus 3 squared, plus y2, negative 3, minus y1 squared. Hey, does it matter which order they're in?
No, because it would just be negative and then you square it and it's positive.
It doesn't, right? Because if I switched it around, guys, look at this. Oops. Negative 3 minus 4 squared plus 2 plus 3 squared. Right? I'm going to get 7 squared or negative 7 squared. Both come up to 49. I'm going to get negative 5 squared and 5 squared. They both come up to 25. So it doesn't really matter which one's x1, which one's x2, or which one's y1, or which one's y2. But you got to make sure you put your x's together and your y's together. Alright? So when I do this, I get the square root of 7 squared plus 5 squared. Well, 7 squared is 49 plus 25 gives me the square root of 74. Now, we're going to leave it like that. We're going to do a simplified radical form for these. So please don't make a decimal, please don't round it. Now in some problems, like the next problem we do, where it's asking us which is a longer segment, which is a shorter segment, you can change them to decimals to figure that out. But our answers when we're asked for distance, we're asking what is the distance between these 2 points, we want in simplified radical form. Now, this one can't be simplified. So this is it, square root of 74. So that's some of you guys clicking away on your calculators. 74 can't be simplified. That's it. Alright. Graph and find the distance of the following. A, B, and PQ. So I'm going to let you guys graph those for a second. Graph A, B, and PQ. Two, 7. 7, 3, 1, 2, 3, 2, 1. Oh, my points are off, that's all right. Alright, which line segment is the longest? AB, probably, right? Just looking at it we can see that. Which one's the shortest?
PQ.
PQ. Now, what would happen if we asked to do this and they looked the same? You'd have to do the distance for them. Well, let's just be safe. Let's find the distance for both of them. I think it should take us 2 seconds. So the distance for AB, the square root, 2 minus negative 4 plus 4 squared plus 7 minus 2 squared. So square root of 6 squared plus 5 squared. So we have the square root of 36 plus 25, which is square root of 51. And you can leave it like that, or because we're going to compare things, I don't want to compare simplified radicals, that'd be a little silly. What?
61.
Oh, 61. Yeah, put 51. Hey, thank you. I bet that's what we're doing all along. Oh. Square root of 61. Approximately what? 7.8, I think is what I got. So, like I said, when you're comparing distances, guys, I don't expect you're going to keep it in simplified radical form. Okay? PQ is the other one. It's the same thing. Let's find our distance. Oh, come on. Why is it being so difficult? Where are we? Alright. PQ, square root 2 minus 7 squared plus 1 minus 3 squared. So we get the square root of negative 5 squared plus negative 2 squared. Square root of 25 plus 4. Or the square root of 29, which is approximately 5.4. So you guys were right, right? AB was longer, PQ was shorter. Thanks. So let me look at that third question. What is the difference in lengths of the two segments? Well, Jalen, welcome back. How do we find that? Just subtract them, right? The difference. So I'm going to go 7.8 minus 5.4, approximately 2.4 units, right? Doesn't tell us a unit. Pretty easy. So, finding distance from 2 points. Super easy, right? Any questions? We look pretty bored. Yeah? Oh, you're not going to get any more excited about midpoint. So, midpoint formula from last year, right? We should all know the midpoint formula. x1 plus x2 over 2, right? Taking the average of the two x's. Same thing with the y's. y1 plus y2 over 2. So, average your two x's, average your two y's, gives you your midpoint. Now, we're going to use it. Right? Find the midpoint or halfway between the points. We're going to use that formula. So let's try it. Once again, does it matter which one's x1, which one's y1? Which one's x1, which one's x2? No. Negative 2 plus 4 divided by 2. 5 minus 1 divided by 2. Right? Plus negative 1, same as minus. So I get 2 over 2. 4 over 2. 1 comma 2. So my midpoint between those 2 points would be at 1, 2. Pretty easy, right?
Yeah.
Pretty standard? Alright. I think the next two are you tries. Find the midpoints. Go ahead and take a look. And if you're gutsy enough, you can put one on the board if you like. If we have volunteers, I guess. You gonna do them, Q?
Yep.
Alright.
I just write the answer.
Well, show your work too. Show that formula.
Alright.
Have we just spent how long learning it?
30 seconds.
Yeah. No, this is your review. If it was a test, Jalen wouldn't be in here. Hayden is not here. Where's Ari? Bryce. Find here. Ramsey. We have homework after this hour. I think so, for the most part. There's probably a couple other things we could do, but that's what the Zoom thing is. You had the other one, Fuji?
Yeah, I guess so.
Alright. Hey, did we all get -1, -3 for the first one? Wow, great response, guys.
Yeah, I did.
Yeah, sweet. Thank you.
I think
coming out here today?
Because he took 2 on his way.
Okay, that was just mean.
I say that every single time.
Yeah, I know, but it's still mean. It's still mean.
Okay, then maybe I would mean it's not to assume.
Yeah, well, maybe you're just a mean person. I don't know.
I mean, ever since Mr. Burling called me mean edgy.
Well, Mr. Burling isn't the nicest man I know either.
Mystery.
What?
Oh, yeah, out of 4.55, he had a 0.4.
Alright, hey, did we all get -1 and 4/2, 4.5, or 9 over 2?
Or had.
I did? Sorry. Page is yours. I gave it to the wrong page. My fault. Alright, we all got those answers. Decimal works, 4.5 is fine. 9/2 works, that's fine as well. Alright? Alright, we have 2 more problems to do. The extension, the application to the midpoint formula is to find an endpoint. So, if we're given one endpoint, we're given the midpoint, we want to find that second endpoint. You guys did this last year, I think, didn't you?
Yeah.
I think so. Does anyone remember how to do it? Alright, let's think about it.
Oh.
Our midpoint formula equals x1 plus x2 over 2. And that gives us the x for the midpoint, right? That, you guys agree to that?
Yes.
x1 plus x2 over 2 gives us the x for the midpoint. Well, I know the x for the midpoint, and I know x1. So can I maybe just plug those in and find the x value for my second endpoint? Right, does that make sense?
Wait, what?
So I'm given the midpoint, so I have an x value for my midpoint,
Alright,
which should go right where the x value for my midpoint goes.
okay.
And I have an x value for one of my endpoints, so I can put that in for either x1 or x2. And then I can solve for the other one, right? Because I want to solve for that second x value.
Yeah,
Does that make sense?
yeah.
You seem really thrilled, Q.
So
You can put it for either one, right? Because I'm just trying to find that other x value. What?
3 minus 2 over 2, right?
Well, it's going to be -2 plus x over 2 equals 3.
Oh!
Right? Because this is for my midpoint. I'm trying to find one of my endpoints. So that's in the middle of my formula. So to solve it, just times 2. Times 2. -2 plus x equals 6. Add 2. X equals 8. So that's the x value of my second endpoint. I don't know if this moves up one whole thing. Yes, that's sweet. So on the y value, same thing, y1 plus y2 over 2 equals the y for my midpoint. Thanks, Emily. So, 7 plus y over 2 equals -1. See, faster, you're good. Okay. See you in a little bit. Times 2, times 2. 7 plus y equals -2.
-9.
Subtract 7, we get y equals -9. So our second endpoint then, where did that go? Should be 8, -9. Alright, now that you guys have that refresher, go ahead and try the last problem. That you try, the other endpoint. That's not our task. And when someone finishes, we can go put it on the board.
Well, we said bang instead
Can I
of
go, Mr.?
Yeah, go ahead.
I'm sure my word.
Yeah,
No.
just put what you started with at least.
Okay.
It's like that first part, like the 7 plus y over 2. Put at least that part.
Wait, who are you filming this with?
I have some people who are gone on my other hours.
You've been gone for a while.
Well, I was filming for Patrick. Well, I was filming for Zach, first of all, who's gone to Florida, I believe. And then I was filming for Jalen, who's gone to California. And now I have other people gone as well. So, just constant. It's okay, I like being on camera. I like hearing myself. It's a joke, you guys can laugh. Uh-huh. Did you say QG?
I didn't do it, but that's like what I started
He needs a
doing.
girlfriend.
Sheesh. Alright, did we all get 9-12 for our second endpoint?
Yes.
Any questions?
No.
Alright,